Okay, let me do now a good lesson. So far, we have talked about midpoint, right? I've also talked about gradient. By the way, gradient is represented by m, okay? And the formula for gradient is y2 minus y1 over x2 minus x1. Okay, so before gradient, actually, there's also a concept of distance, okay? Distance of a line. So if you have a point here and the line is like this, another point here, A, B, right? So this one is 2 comma 1 and B it's maybe 4 comma 3. Okay, the distance of AB or the length of AB is given by distance distance. Oof, I'm not used to I'm not yet used to this new phone. So distance is equal to, you do this square root, open bracket, x1 minus x2 squared plus y1 minus y2 squared. Okay, so there's a square here and a square here. Okay, so x1 minus x2 squared plus y1 minus y2 squared. Okay, the naming way, the way to name them is the same. This is x1, this is y1, this is x2, this is y2. Okay, so this is the formula for distance. Okay, then let's do an example. So I'm going to rotate my phone. So let's say we've been given point A 2 4 and point B negative 1 0. Okay, then they want us to find distance or length of A, B. So A and B are just 2 points, okay, which are on the line. So they want the distance from A to from A to B. Okay, so that's what they want in this phone also. Okay, so this is A and this is B. So they just want the distance from here to here. Okay, so you just have to use the formula. Distance is equal to square root of x1 minus x2 squared plus y1 minus y2 squared. Okay, so you have to name them x1, y1, x2, y2, right? So distance will be equal to square root of, what is our x1? Our x1 is 2 minus x2. x2 is minus 1. Remember, minus 1, you have to be careful. You have to put it in brackets like this. Okay, plus what y1, what is y1? 4 minus y2 0. Okay, square root. So it's going to be distance is equal to square root here minus times minus, it's plus. The brackets mean times. Remember, these brackets, they mean this sign times this sign, so it's plus. So it's 2 plus 1. Okay, so it's like this, 2 plus 1 squared plus here 4 minus 0, it is just 4 squared. Okay, so I'll continue from here. So we have distance equal to square root of 2 plus 1 squared plus 4 squared. So distance is equal to square root of 2 plus 1 is 3 squared plus 4 squared, it's 16, right? This is squared. Okay, so distance is equal to 3 squared, it's 9 plus 16. Distance is equal to square root of 9 plus 16, 25. So distance is equal to square root of 25, it's 5. Okay, so you have to put the word units. That's all. That's all about distance. It never gets complicated. Okay, the next concept is equation of a straight line. Okay, so the equation of a straight line is like this. So when they say equation of a straight line, it's something like this. Okay, so in this case, m is the gradient. Okay, m is the gradient and c is the y-intercept. What's the gradient and the y-intercept? Remember these two lines and maybe the third line. Okay, this line and this line, they have different gradients because the way they are oriented in space are different. They are bent in a different way. Okay, but this one and this one have the same gradient because they all go like this. Okay, the only difference between this line and this line is where here this one is cutting the y-axis here this one is cutting the y-axis here. Okay, so the only difference is the y-intercept. So the m tells us how it is oriented in space, the gradient. The c tells us where it's cutting the y-axis. Okay, so any line, so long as you know the m and the c, then you can write the equation of that line. Okay. Okay, now let's go to mathematics. So if they have given you something like this, okay, let me start with something simple. So they have given you, this is the line, the equation of the line. So if they ask you to find the gradient of this line, okay, they want you to find the gradient of this line, what are you going to do? Okay, you compare this with the equation of a straight line. Okay, this is the equation of the straight line. So if you compare, you can see that 5 is the m, therefore gradient is 5, and 8 is the c. Okay, therefore y-intercept c is equal to 8. So it means you have identified your gradient and your y-intercept. Okay, let's look at this. 2x plus 8y 7. Okay, what is the gradient and the y-intercept? So for you to find the gradient, you have to write this in the standard form, or in the form like the equation of the straight line. It should be like this. Okay, the y should be alone here as a subject, then the x should be here, and the c should be here. C is just any number. Okay, so in this case, let's make y subject. So we're going to take 2x this side, so it will become 8y 7 minus 2x, right? We can even write like this. Since we want the x to be after the equal sign, so we can write the negative 2x. Then this number, what is this number? 7, but positive 7. So you write it as positive 7. Remember, the positive is invisible. Okay? After that, you divide everything with 8. Okay? Everything with 8. So this and this cancels. So you have y is equal to negative 2 here 1, 2 here 4. So it will be negative x over 4, okay, plus 7 over 8. Okay, here you cannot reduce, so you leave it like that. So this is the final equation where y is the subject and this starts with x. I mean, x is just near to the equal sign, just like here. Okay, so now what do you do from here? So I'm going to erase everything. I'm going to take this. Okay, so we're going to have y is equal to negative x over 4 plus 7 over 8. Okay, so now if we compare with the standard equation of the straight line, we can see that m is the coefficient of x, right? The number in front of x. What is that number? Remember, there's an invisible one here, so it's negative 1 over 4. Okay, you have to get even the 4 on the bottom. So this is our m. Okay, c is the number that remains here, the 7 over 8. Last one. What if you have y, let me see, 2x plus 5y 3 7. Okay, so okay, let's put negative 7 here to make it more interesting. So the first is to make y subject. How? You put a 1 here, you do cross multiply. So 1 times everything here, we're going to have everything, which is 2x plus 5y. Okay, 3 times negative 7 is negative 21. Okay, 3 times negative 7, right? From here, we take 2x this side, so it will be 5y. In fact, now, when you take 2x this side, you should even be writing it first. It will become negative 2x, right? But you write it first. Then negative 21 remains here, right? Then you divide this side by 5, everything by 5, everything by 5. This and this cancels. You have y is equal to negative 2x over 5 minus 21 over 5. Okay? From here, you can tell that your m is the coefficient of this. So gradient m, it's your gradient m is negative 2 over 5, right? negative 2 over 5. And your c is negative 21 over 5. Don't forget the sign, negative 21 over 5. So your c is negative 21 over 5. Okay, that's your c there. Okay, so these are simple questions, but now let's picture a situation where we've been given 2 points. Let's say point A, which has the coordinates 2, 0, and point B, which has coordinates 3, 3. Okay, so if they ask us to find the equation of a straight line connecting AB, or the equation of line AB, okay, so they want us to find the equation of this line AB, the straight line. Okay, remember the equation is this. Okay, this is the equation of a straight line. Okay, so all we need is M, okay, and C. Okay, so the first step is to find M. M is the gradient. So the formula for gradient, like we discussed, y2 minus y1 over x2 minus x1. Okay, the first step is to name your coordinates x1, y1, x2, y2, right? So after that, you are going to have M is equal to y2 is 3, minus y1 is 0, x2 it's 3, y1 it's 0, right? Sorry, x2 is 3 minus x1. Okay, x1 is 2, so it's going to be 3 minus 0, 3, 3 minus 2, 1. So our M is 3 divided by 1 is going to be 3, right? So our M is 3. This is our M. Once you find your M, the next job is to find your C. Now here there are 2 methods. There's a method that I like and the method that students like. Most students like the second method. So I'll start with my method, then after that I'll go to the method that most of my students like. It's up to you to choose which one you're going to go for. Okay, so now that we have the gradient 3, so let's not forget the coordinates 2, 0, and B 3, 3, right? Okay, so our M was 3, right? So my formula is simple. So you like the equation of a straight line. I mean my approach. Okay, so where there's M, you put your 3. Okay, X plus C. To find the C, you pick any of the coordinates. You can pick this or this, whichever you like. Me, I like 0. In mathematics, I like 0 because it makes life so easy. I don't like negatives. I like positives. Then after positives, I like 0. So I'll pick this one with 0, 2, 0. So on this one, X is this is Y, right? This is X, this is Y. So we pick the Y 0, we write it here. Okay, so where there's Y, we write 0 equals 3. Then where there's X, we put 2 there, plus C. So it will be 0, 3 times 2, 6, plus C. 6 can go the other side, it becomes negative 6 equals C. Therefore, okay, we have the C now. So we can rewrite this. Where there's M, we put the gradient. Where there's C, we put the C. So it becomes Y is equal to, what is the value of M? M, we know it's 3x. What is the value of C? C, it's minus 6. This is the answer, the equation of the line. Okay, let's look at the other approach, the approach that my students like. Okay, so again, the coordinates are 2, 0 and B 3, 3. So we had found the gradient to be 3, right? So after finding the gradient, then most of my students have this formula. Y, so it's X minus X1 equals, you have to put M outside. Let me just write it properly. M X minus X1 equals Y minus Y1. Okay, so your M, you write it here, 3. X, you just write X. Again, just like my method, you have to pick either this or this. Again, I love zeros, so pick this one, okay? But the answer is going to be the same whether you pick this or this, okay? So in this, we know that this is our x and this is our y, okay? Therefore, our x1, we bring it here, okay? So it's x minus 2, y minus, our y1, it's 0, okay? So it's going to be 3 times x, 3x, 3 times negative 2, negative 6, equals y minus 0, y. We can write it as y is equal to 3x minus 6. So you can choose whichever you're going to like. Okay? So now, the last concept is about parallel and perpendicular lines. Parallel and perpendicular lines. Am I pronouncing that right? Parallel and perpendicular lines. Okay, so now if we look at, if this is the x or y plane, we have x, we have y, we have o. If this is a line and there's also another line like this, these lines, no matter how you extend them, they will never meet. Hence they are called parallel lines. What have we been talking about? The nature of these lines. What properties do they share? They have the same orientation in space. Therefore, they have the same gradient. Okay? These two lines, they are very different from this. This one is going to meet them, right? But these two, they can never meet. Okay? So, of course, this has a gradient and this has a gradient, and their gradients are the same. So, if this is gradient 1, this is gradient 2, so gradient 1 is the same as gradient 2. So, for two parallel lines, they have the same gradient. Okay? What if now there is a perpendicular line? A perpendicular line is a line 90 degrees to another line, okay? So, if this perpendicular line has a gradient called m3, then the gradient of m3 is equal to negative 1 over the gradient of m1. That's how it works, okay? The gradient of the perpendicular line is negative 1 over the gradient of this line. Yeah. It's very important to visualize this, but yeah, who cares? Let's look at the mathematics. How can a question come? I think that's what most people are interested in. So in that case, let's say there's a question given that, the question can be, find a line perpendicular, okay, find the equation of a line perpendicular to, I like 2x, I don't know why. So 2x minus 4y. So find the equation of a line. First, let's start with parallel. Okay, find the equation of a line parallel to this. They want us to find the equation of a line which is parallel to this. And this line is passing through a point M. Not M, M is a bad, okay, let's say Q. 4, 0. Okay, find the equation of a parallel line to this line passing through. So this parallel line, if you want to picture it, we have this line which can be something like this. Then we have a line parallel to it, but this line which is parallel is passing through a point called Q. Okay, which is 4, 0. Or this Q can be where they are meeting, who knows? But the point is, it's passing through a line Q which is 4, 0. So how can we find the equation of the, let me say that again. Whew. We have this line. So now we have a line parallel to it. I was describing perpendicular. So this is the parallel line, right? So this is this. Now there's this line which is perpendicular, which is parallel, okay? Not perpendicular, sorry. And it's passing through a point Q, 4, 0. Okay? So all we need to use this line. We get the gradient of this line. Once we know the gradient of this line, then we'll be able to know the gradient of this line, because the gradient of the first line is the same as the gradient of the second line. You see the thinking there? Okay, so with that being said, let's see how to solve it. It's very important to visualize in coordinate geometry. Okay, so now solving it, we're going to say what is the gradient of this line? Okay, so the gradient of this line, we know it's we get the equation. We don't have to use the formula because we haven't been given 2 points, but we've been given this. So this one, y is already the subject, so it's simple. We just write it, okay, like this. So m in this case is 2. Otherwise, if it wasn't the subject, you're supposed to make it the subject. So the gradient is 2. Once you have the gradient, then we go to the next step. Okay? So the next step now, we forget about this line. We think about the parallel line. Okay? So for the parallel line, we know that the gradient is 2, right? Because m1, the gradient of the first line, is equal to m2, the gradient of the parallel line, which is 2, right? So now, with this information, we can say, okay, now, which method should we use? Should we use my method or student's method? We're going to use student's method because I also think it's short. So m is equal to y2 minus, x minus x1, y minus y1. Okay, so m is 2, x minus x1, we pick from where it's passing. Okay, so this is our x1, this is our y1. So x1 is 4. Okay, y minus y1 again is 0. So 2 times x, 2x, 2 times -4, -8. Okay, y minus 0, it's y. So this is the equation, okay, of the parallel line. Okay, y is equal to, if you want, you can even write it as y is equal to 2x minus 8. Okay, let's look at another question. Let's have been given this equation. Okay, yes, so they have said find the equation of a line perpendicular to this line. So this line can be something like this, okay. So now they want us to find the equation of a perpendicular line. Okay, so this perpendicular line, so the question says find the equation of a perpendicular line to the line 3y equals x and passing through a point P 4, 4. Okay, so this passes through a point P 4, 4. Or sometimes they like to say find the equation of a perpendicular line meeting the line 3y is equal to x at P 4, 4. Hope you can visualize what I'm saying. So it's just a perpendicular line to this line. This line has this equation. So they also want us to find the equation of this one. But the only thing we know about this one is it's perpendicular and also it passes through this point. What do we do? Okay, enough of the drawings. Let's go to the mathematics. So these are simple things. There's no magic involved here. It's just simple mathematics. So we have 4, 4. So the first thing is to make y subject in this case. Okay, so remember we want it to look like this. The reason why I want it to look like this so that we can know what the gradient is. Once we know the gradient of this line, then it is easy to get the gradient of the perpendicular line using the formula. Gradient of the perpendicular line, let's call it m3, is equal to -1 over gradient of the parallel line. The gradient of the given line, m1, right? So we're going to say, for this, we have 3y equals x. So we can divide everywhere by 3. So it's going to be y is equal to x over 3. Okay, so this is the equation of the given line. Okay, so now let's get the gradient from there. So I'm going to erase everything. This video can pause in case you want to copy. Don't forget that. Okay, so we have y is equal to x over 3, right? If we compare it with y is equal to mx plus c, we can see that c, there's nothing, so c is 0. There's nothing. There's no plus anything here, so there's just plus 0 here. Okay, then m, okay, m, the coefficient of x, it's 1 over 3. So gradient is 1 over 3. Okay, now to find the gradient, this gradient is for the given line. Okay, now to find the gradient of the perpendicular line, we're going to use this formula. Okay, so we have 1 over 3 as our m1. Okay, so we're going to say, let me just erase all this. Okay, so we're going to say m3 is equal to -1 m1, which is 1 over 3. You have never seen this, right? But simple. If you want to simplify this, you just have to bring this on top and this on the bottom. That's all. Okay, or like this if you want. So this one, you write it the way it is, -1. Divide, you turn it into times. Okay, when you do that, this goes on top, this goes on the bottom. Remember how you divide fractions. For those who still remember to divide fractions, if you have something like 2 over 3 divided by 1 over 4, for you to divide, you say 2 over 3, then you do times. Then this number, the 4 goes on top, the 1 goes on the bottom. Okay, so even here, this is divide. So it's -1 divided by 1 over 3. Okay, which you can write as -1 times, then the 3 goes on top, the 1 comes on the bottom. Okay, so it's going to be -1 times 3 over 1, which is -3 over 1. Okay, but most of the times when you have such a fraction, okay, when you get a fraction, it's simple, because most of the times they like bringing it like this, so you don't have to worry about this. All you have to do is, the answer is, you just pay attention to this. The -1 will always be there when you're doing this question, so just pay attention to this. You take this on top, this one comes down. Okay, so it becomes 3 over 1, and you always put a negative. If it's negative, what is on the bottom, if it's negative, it will become a positive. Okay, so in short, when you have 1 over 3, the answer is going to be -3. What if you have 2 over 3? The answer is going to be -3 over 2. Okay, you see the pattern? Okay, so the pattern is simple. Let's say you have if you have 1 over 3, it's going to be -3, because there's a 1 here. Okay, if you have 4 over 5, it's going to be -5 over 4. We take this up, this down, then we put a negative. If you have 2 over 100, it's going to be -100 over 2. If you have 7 over 19, it's going to be -19 over 7. Okay, what if you have 2? After you can't have that. No, you can't have that. It's not possible. Yeah, you can have. So what if you have -1 over 2? What happens? In that case, you don't need to solve, right? Okay, I just wanted to show you different patterns. Okay, so if in case you have found your m to be 2, you just have to write it. There's no need to solve. But in case you have -1, then on the bottom you have such a thing. Okay, you just take this up, this down, then you change the sign. If it's negative, it becomes positive. If it's positive, it becomes negative. Another way in which you can look at this is you can look at it as integers. Okay, so in that case, this can be like power 1, so to be -1 over 3 power. When it goes up, it becomes -1 as well. Okay, this may be confusion. Let me just leave it here. Okay, but I hope you have understand, you have gotten the pattern. Okay, yeah, the easiest way is just to take this up, this on the bottom, then you change the sign. Okay, so our m3 is, when we take this up, it will be 3 over 1. We put a negative, right, because this is positive, so this is going to be -3. That's the gradient of the perpendicular line. Now we need the equation of the perpendicular line. This is just the gradient of the perpendicular line. So remember, it passes through P 4,4. So we forget everything about the first line. So we just have P 4 over 4 and M -3, right? So we're going to say M y minus y, x minus x1, y minus y1. Okay, so it's going to be M is -3, x minus x1 is this 4, y minus y1 4. Okay, so -3 times x, -3x. -3 times -4, it's going to be +12, y minus 4. Okay, so now the job is to make y subject. So -4, we can bring it here so that it becomes -3x plus 12 plus 4 equals y. So -3x plus 16 equals y. Therefore, our equation is y is equal to -3x plus 16. This is the equation of the parallel line. We are done.